today's class we are going to review angles in mathematics, and we will also look at the interior angle sum of polygons. So just quickly review of what an angle is. So it's defined as two rays. So here we have ray A and we have ray C, and they are converging at one point. That's called the vertex. So right here, shown at point B here, we have the vertex. So when we name angles, we use this symbol. It looks like this. And then we usually use 3 capital letters, and that middle letter always represents the vertex. So in this case here, the angle here would be B. So sometimes it's written as angle B, but other times you'll see it written as angle ABC. So again, that middle letter represents the angle. So this angle here. So be aware of both methods of writing angles. And then angles are expressed by using the units degrees with the symbol, the little circle as a superscript. So for example, in a circle, in one complete rotation or revolution or circle, it is 360 degrees. Here we see a protractor. This is being used to measure and draw angles. And in this case, we have angle BMR. Okay, so shown here. And if we look at the measurement of this on the protractor, it is at 130 degrees. All right, so if you were to note here, it's going up by 10. So 10, 20, 30, 40, 50, 60, 70, 80, 90, and so on. So right here would be 130 degrees. Okay, just some vocabulary here, terminology for angles. We have the acute angle, so this is any angle that is less than 90 degrees. We have the obtuse angle, which is greater than 90 degrees, but less than 180 degrees. A right angle is any angle that is 90 degrees. So anytime you see that little square there in the corner, that represents a 90-degree angle. A straight angle is 180 degrees, which makes sense. If we drew a perpendicular line here through this point, if we drew a line here, you would have two 90-degree angles, which make up 180. So 90 and 90 together, the straight angle would be 180 degrees. 180 degrees. All right, a reflex angle is greater than 180 degrees, but less than 360 degrees. All right, so this angle shown right here would be the reflex angle. Next, we are looking at congruent angles. So these are any two angles that have the same measurement. So congruent means an equal measurement. So here we have a 30-degree angle and a 30-degree angle, so therefore those are two congruent angles. All right, so next slide here, we're looking at some more terms. Our first one here is adjacent angles. Adjacent means beside. So here, the definition of adjacent angles are two angles that share a common vertex and a common arm. All right, so this angle and this angle, these two angles would be adjacent angles. Complementary angles, these are two angles that will add up to 90 degrees. So for example, 40 degrees and 50 degrees, those will add up to 90 degrees. You could have another example could be 30 degrees and 60 degrees. Those would also add up to 90 degrees, and like 20 and 70 and so on. So any two angles that add up to 90 degrees. Right, supplementary angles, these are two angles that add up to 180 degrees. All right, so an example here is 120 and 60 degrees. Those add up to 180 degrees. All right, a linear pair would be two adjacent angles. So again, adjacent angles like this, they are adding up to 180 degrees. Next we get into opposite angles. So we have here two lines or two rays, two lines that are intersecting, and you can see here that the opposite angles are congruent. So these are congruent angles that are formed when two lines intersect. So x here, those two angles would be congruent, and then these two angles here, shown with the dot, those two angles would be congruent as well. All right, here we're looking at a transversal. A transversal would be this line going through two other lines. Okay, so this line here that is intersecting these two lines, this line here is the transversal. And so next we're looking at diagrams that deal with the transversals. So we have here corresponding angles. So corresponding angles are congruent if line 7 and line 8 are parallel. So you'll see there a symbol that looks like that. That means parallel. And then when you see the equal sign with the little squiggle on top, that is the symbol for congruence. All right, so again, congruent means the exact equal shape and size. So here, these are corresponding angles here. So X and X, M and M, O and O, and then closed dot, closed dot. Those are all corresponding angles. And they are congruent. All right, here is just showing two parallel lines. Like I said, it would look like this. So again, two parallel lines are shown like that. All right, parallel again, they will never intersect. They're equidistant apart at all times. So the distance between the two lines stays the same at all times, kind of like train tracks. So in math, parallel lines, they'll never intersect. Here we have perpendicular lines. This is when two lines are intersecting and they are meeting at a 90-degree angle. All right, so that is what perpendicular means. And that is the symbol for perpendicular. It'll just look like kind of like an upside down T, capital T. That is showing perpendicular. All right, so next we get into interior alternate angles. So again, line 1 and line 2 are parallel to each other, and therefore the interior alternate angles are congruent. So this angle here, X and X, those are the interior ones. They're on the inside, and therefore X and X, those are the two interior alternate angles, and so are the two closed dot angles. And again, that works if line 1 and line 2 are parallel. Then we have the exterior alternate angles. So notice now they're on the exterior or on the outside. All right, so we have the circle and circle, and then we have the dot and the dot. Okay, and notice again they're diagonal or alternate to each other. All right, and again, exterior alternate angles, they are congruent if line 4 and line 5 in this case are parallel. All right, so for these examples here, we have to figure out the measure of the angle labeled X without using a protractor. All right, so we have a straight line here. We know that's 180 degrees. So we would take 180 degrees, subtract the 63 degrees here, which gives me 117 degrees. All right, so here X is equal to 117 degrees. Here, again, we have a straight line. A straight line has a measurement of 180. So 180 minus 135, which gives me 45 degrees. All right, in this example, we have three angles. We are making one complete revolution, so that is 360 degrees. And then we would just subtract the 169 degrees and subtract the 70 degrees, and that'll give us the answer for X, which gives me 121 degrees. All right, so for this example here, we have to figure out the measure of the missing angles. So we have A, B, C, and D. All right, so figuring out D here, well, this is a straight line, and we know part of this is 70, so we know that this part has to be 180 minus the 70. All right, so to figure out D, we're going to take 180 degrees and subtract the 70 degrees. And that'll give me the answer for D. Okay, so that gives me 110 degrees. All right, the other thing we can figure out here is angle 70 degrees here, and angle C, those are opposite angles. All right, because we have this line and this line intersecting. So these two angles are going to be opposite angles. So therefore C is going to be 70 degrees. All right, and then the theory of opposite angles. So again, angle D here is opposite to angle AB, but we also know that angle A and angle B are equal to each other. So to figure that out here, all we're going to do is take the 110 and we'll just divide it by 2. And that gives me 55 degrees. All right, so angle A is 55 degrees, and then angle B is 55 degrees. All right, and to check this, all of these angles together should add up to 360 degrees. All right, so let's just write all of that out here. So angle A is 55, angle B is 55 degrees, angle C is 70 degrees, and the angle D was 110 degrees. All right, so if you add up all those together and the 70 degrees here, it should equal to 360 degrees. The next part of the lesson today is the interior angle sum of polygons. So this is showing 3 different methods here to figure out the interior angle sum of all polygons. All right, so the first method would be protractor method. So you would just measure each angle inside of this polygon and then add them up. It tells us here that it would become, the answer would be 540 degrees. There's a formula method, interior angle sum, so IAS is equal to 180, and then in brackets we have n minus 2. N represents the number of sides in the polygon. So in this example, we have 1, 2, 3, 4, 5. It's a 6-sided polygon, so it's a hexagon. So in our formula, we would have 180, and then 6 minus 2 in the brackets. Okay, brackets are done first, which gives me 4. 180 times 4 gives me 720 degrees. All right, so this is a hexagon. The interior angle sum of the hexagon would be 720 degrees. If we were to do the angle or the formula method for this one, I'll just do it right here. So it would be 180, number of sides, 1, 2, 3, 4, 5. So 5 minus 2, which is 3. So it would be 180 times 3, which gives me 540 degrees. All right, so that's for that example. And then the last method is the triangle method. So you can choose one vertex on the polygon and then draw triangles. So from this vertex, we draw one line, another line, another line, another line. Count how many triangles we have. We have 1, 2, 3, 4, 5 triangles. And we know that one triangle, the sum of all the angles in one triangle is 180 degrees. So here we have 1, 2, 3, 4, 5 triangles. So 5 times 180 degrees, which gives me 900 degrees. All right, we could do that similarly to this one here. We can choose this vertex and we can draw triangles, one, another one, and another one. So here we end up with 1, 2, 3, 4 triangles. So we could do 4 times 180 degrees, which would still give me 720 degrees. All right, so those are the different methods we can use to figure out the interior angle sum of polygons.